Hey, good evening, everyone. Welcome to O-Level Physics lesson. My name is Mr. Chu. Today is Tuesday, 21st of June, 2022. And we're going to start practicing on practical electricity questions. Okay, so we have, I have one check-in question for all of you. I think most of you got it correct now. So before this topic, you all will have, all of you should know these two formula. Okay, power equal energy over time is in Newtonian physics under chapter 6 or 7. Okay, the topic of work, energy, and power. Okay, you learned this earlier on last year. Then in the topic of current electricity, you learn V equal to Ri or V equal to IR. Okay, so for this topic, you only need to remember one formula. Okay, so what's the one formula that you need to know? I will do in bold. It will be power equal to VI. Okay, to calculate the power of a device, you just need to get the product of its voltage and its current. Is that clear? And then we use Ohm's law, this one. We substitute the V or the I from Ohm's law into this formula. You'll be able to get the other two formula. Okay, so for example, if I substitute this V with Ri, I can say that you will get Ri squared. Can you see that? If this V is replaced by Ri, the V is replaced by Ri, you'll get power equal to Rii, which is Ri squared. Likewise, if I replace I with V over R, you'll get V squared over R. Okay, so these three formulas are the same. So the question sometimes will have one missing variable. For the first example here, the missing variable is a resistance. So okay, what I mean is, no, I'm not missing. They provide two of the three variable. In this case, the 2 out of 3 is V and I. Second case, the two variable is R and I. And the last case, the two variable are V and R. Is that clear? Okay, so this formula, if I rearrange, I'll get E equal to PT. Okay, so your energy, you just follow whatever is on top. Whatever is P, you times the time. So VI is the P, right? I just write down VI. I add the time behind. Is that clear? Same thing. This is your P. I bring down the whole thing. I add the T behind. Okay, because this whole thing is the P. Okay, this whole thing is a P. And you know that energy is P times T. Okay, so whatever is on top here, you just add the time behind. Okay, the last one will be V squared T over R. Okay, so can you see over here? The bottom three formulas are similar to the top three formulas. The only difference is, you add a T into each formula. You add a T into each formula. Is that clear? Reason is because this is your P. This is your P, and this is your P, which is what you see on top here. Can you see that? This three on top here is all your P. Okay, so for this topic, you just need to remember this formula in green, plus the other two formula that you learned in the previous topic. This one and this one. So you know these two formula in your previous topic. And for this topic, you just need to remember this formula in green. You'll be able to derive the other 5 formula here. Is that clear? Ken, did I make it easy for all of you? Okay, if it's okay, give me a thumbs up. Ryan, why give me a cross? Okay, Chelsea, are you okay? All right, let's continue. Okay, so today we're going to do the MCQ questions. Okay, let's do question 35 first. Okay, we have done this last time. So let's look at this question. Okay. Let's do this question. Everybody, you may begin. Oscar, well done. Yu Ting, well done. How about the rest of you? Chelsea, incorrect. How Ray, well done. How Ray, why you share your answer with everybody? See now, Ryan copy your answer. Ryan, can you do the working onto the screen? Wow. Ryan showed me an answer that is amazing, which I never think of before. Okay, well done. Xiao Xing, well done. Bei Kuan, well done. Okay, so what? Let me share with you what Ryan did, which I did not think of before. So can you see over here? For this question, okay, we all know that power is equal to V times I, correct? So can you see for each of these bulb, you are given the power as well as the voltage. So you're given the power, you have the voltage. Can you find the missing variable I? So for each bulb, you find the current, and then because this is a parallel circuit, this I here will be equal to the sum of these two current. You should be able to get the answer 0.758. Okay, so that is the easy way of doing it. You find the individual current passing through each bulb, then you sum up the two current together, you should be able to get the answer for I. However, I see that Ryan and Chelsea use another method. Okay, so what they do is they find the total power. In this case, it will be 6 watt plus 12 watt equal to 18 watt. And you see that this whole circuit is powered by a 24-volt battery. Is that clear? So the total current to be equal to total power divided by total voltage. So you get 18 over 24 and you get 0.75 ampere. Okay, so this method is used by Ryan as well as Chelsea. I have not thought of this method. Okay, but it's also correct. You get the same answer, but I will recommend you all go and count the individual current. At least you know the basic fundamental of what current is. Okay, so this question, all of you got it correct. One of you got it wrong, but you managed to recover. So well done. Okay, let's do the next question. Okay, let's do question number 36. Okay, you all may begin. Okay, you all may begin. Oscar, try again. Yuting, correct. Xiaoxing, Ryan, try again. Hao Rui, well done. Xiaoxing, correct now. Beihuan, incorrect. Incorrect. Okay, basically for this question, you just need to know this formula. So which, okay, so another thing is this, electrical energy at the greatest rate. Electrical energy is E. Greatest rate is divided by T. So what is E over T? Okay, which is, you're trying to find the power. So for this question, you're asking which of these four circuits has the greatest power? Understand? And the greatest power means it uses up the most energy every second, okay, over a unit time. So which of these four circuits will use up the greatest amount of energy, okay, over time? Okay, Ryan and Beihuan, you got it correct now. Well done. So who else haven't got it correct? Who haven't given me the answer yet? Oscar, how about you? What's your answer for this? Okay, left with Oscar. Okay, so let me talk about this. All of them okay, all of them, can you see, have a fixed battery. Okay, so their V is fixed. Okay, it doesn't change. Okay, so the V doesn't change. Okay, the value of V is fixed. Is that clear? Okay, the value of V is fixed. So to determine the power, you need to have the greatest the power, your current has to be the greatest. So you just observe these four resistor configuration. Okay, which one will give you the greatest current? The one that have the greatest current will have the least resistance. Okay, so you know that when there are more resistor in parallel, the resistance for this is the lowest. So therefore, the total current here is the highest. Is that clear? Now, we use another method. We change the formula. Remember, we talked about the formula. This question, there's only battery, the voltage, as well as the resistance. So there's no current. Okay, so resistance is equal to V over, let's try, V equal to Ri. So I is equal to V over R. So I change this I equal to V square over R. Clear so far? And we know that the V is fixed. So for the power to be the greatest, your resistance need to be the smallest. So you look at these four configuration. Which one has the lowest resistance? Okay, the answer will be D. Okay, so the answer for this will be D. Oscar, are you there? You understand this question now? Okay, you get it? Okay, so you either compare which one has the greatest current, and you know that the circuit with the most parallel will have the greatest current. Okay, or which of these has the lowest resistance will give you the greatest power. Is that clear? Okay, let's do the next question. Okay, the next question, let me see. Okay, all of you now look at question number 35. Okay, you all may begin. Question number 35. Okay, some of you got the answer already. Yuting, well done. Xiaoxing, well done. Oscar, try again. Ryan, try again. Howry, well done. Oscar, you got the answer correct now. Okay, this is the question is, remember the other time we talked about life. Okay, all your safety feature should always be wired to the live conductor. Why? If the switch is wired to the neutral conductor, what happened? Do you remember this question? I got the live and the neutral. This is my device. If I put the switch at the neutral, even when the switch is open, the device will not work. But the live has a voltage of 230 volt. Okay, so this whole circuit has a potential of 230. But because there's no potential difference, the appliance will not work. But because it's a high potential, your finger put here, your finger has a 0 volt potential, right? And you touch the device or the wire or any of the exposed area, because of a potential difference of 230 volt, current will flow through your hand. Okay, then it becomes very dangerous. Okay, so even if you switch open, Then you thought that there's no current going through. You try to repair the thing, but the whole thing is connected to the live wire, and the live wire has a high potential. So when you try to repair the thing, you think that it's not working, then you go and touch a wire or touch a metal, you will get shocked because you have a very low potential. The device has a very high potential. There is a potential difference. Current will flow. You understand that? Then current flow, you get shocked. Too much current flow through you, you might get electrocuted and die. Okay, so in this case, what would the answer be? Okay, the answer for this would be A. Is that clear? All right. So all okay now. Let's go to the next question. This question I did not go through last week because I did not go through the picture of a plug. So this time around, you get to see a picture of a plug. Okay, let's take a look. Okay, so for this question, the first time you see a picture of a plug. Okay, this question appeared 2 times in the past 10 years. The first time is 2014, and then it appear again in 2019. Okay, so this is a 2014 paper. Okay, go and try again. Then I'll talk to you about the plug in a while because last week I did not show you any picture of the plug. Okay, start doing now. Okay, let me look at the answer that's given by your Hao Rui correct, Bei Kuan correct, Yu Ting try again, Oscar try again, Ryan well done. Oscar try again. Yu Ting try again, Qiao Xing well done. Okay, what is wrong with this diagram? Okay, what is wrong with this diagram? Let me explain to you. Okay, let's look at this plug. Okay, I did not go through the plug much last week, so let me just explain the plug to you all first. Okay, first of all, when you open up the plug, do you know that some of the plug that we have are the 2-pin plug? Correct, the 2-pin plug. Okay, the 2-pin plug, one will go to live and one will go to neutral. Okay, and then it will work. So there's no earth. Okay, so among these 3 pins, which one will be the earth? Okay, which one is the earth? The earth will be the one at the top, because the 2-pin plug do not have the top pin. Clear so far? Okay, then remember I told you all safety device is always connected to the live pin. Okay, so you see, fuse is a safety device. So this pin actually connect to the fuse. So this pin is your live wire. Clear? Then your last remaining pin will be your neutral. Can you remember that? Okay, so the 2-pin plug has no earth. Okay, you can imagine how the 2-pin plug looks like, right? Okay, so the one on top that is missing will be the earth pin. Okay, the earth pin. Then the safety devices like a fuse is always connected to the live pin. Okay, so the pin that is connected to the fuse will always be live, and then the neutral is the last remaining one. Okay, then how to remember the color? Okay, earth itself has a lot of trees, correct? So just remember earth as a green color. And then live wire is the most dangerous among the 3. So the most dangerous color is actually red. So just remember that the live wire is red, and the color that's close to red is also brown. So anything that's very red or brown, okay, that will be your live wire. Then neutral is a very neutral color. It's a very calming color. So therefore, the blue wire will go to your neutral point. Can you remember that so far? Okay, so now look at this. How do you actually, if you want to play with your plug, right? First of all, remove this screw. Remove this screw. Okay, and then this plastic take out. Clear? Then your wire, you put in firmly, don't have stray wire. Then you screw in this screw to actually position the wire properly. Can you see what I'm talking about? Okay, same thing. There, this screw itself, you unscrew. You put the wire inside firmly, no stray wire. Then you screw in all the way so that the wire is in place. Okay, you do that for all 3 places. Okay, make sure that there's no stray wire. Okay, your wire should be all inside this hole here. There's a hole on top here where you can slot in the exposed wire. Once you slot in, you screw in totally in. Okay, you do that for this 3 part. Okay, so far? Okay, once you are done, you just arrange the 3 wire properly, tuck it inside. Okay, normally your wire has 1 big insulation. Then you have three wire coming out. Then these are the wire, correct? Okay, so these 3 wire have different color. So this outer insulation, you put it inside. Put it inside your plug. Okay, put it inside your plug, not outside. Okay, you don't put this wire outside where you can see the 3 color. You look at all your plug, you don't get to see the 3 color inside, right? So this outer insulation, tuck it in. If you want, you can tuck it even below this plastic thing. Okay, this outer insulator, you can tuck it just below this plastic thing. Okay, so everything is put in properly. You put the plastic over, press against this wire here. Okay, you press the plastic over this wire here. So this thing that I'm putting here is this slab here. Then you screw in these 2 wire to put all the wire in place. So actually it's not hard. Then once that like that is done, you are ready to go. Okay, then if you were to take out your 3-pin plug, you can look at the fuse rating. Okay, the common rating that you might see could be like 13 ampere. What does 30 ampere means? 30 ampere means if there's any current above 30 ampere, this fuse will break. The whole thing will not work. Okay, so how do you actually make it work again? You replace the fuse with a new one. You can always buy a fuse at the hardware shop. But don't do that. When it fuse means something is wrong. Go and find out what is wrong first, then you replace. Because you can replace it, it can still work. But if your problem is not rectified, you will fuse again. But of course, you can pray that that one time is just the rare time. Then you will not fuse again. But the proper way is to check where goes wrong. Okay, then you put back the fuse. Is that clear? Then, can you use a 2-pin plug and change to a 3-pin plug? You can as well. Even though there's only 2 wires here, for this our plug, those are 2-pin plug. Okay, there's only 2 wires, right? So the wire, there's only 2. You can still do the same thing. You plug the correct color into your neutral and your live, it will still work. And then a 3-pin plug is easier to plug into the Singapore plug, correct or not? Because for a 2-pin plug, it cannot go in by itself. You need to have the 2-pin plug adapter. Or if your parents have taught you before, you take a pencil or a pen, go and poke into the earth hole. Have you seen that before? Poke into the earth, pull it down, then the bottom 2 latch is already open, then you can plug in the 2 plug. Okay, but they are dangerous. You don't use a metal pen. Okay, but earth point is fine. You shouldn't get electrocuted. Make sure your pen don't go into the live point. Go into the earth point and make sure the switch is off. Yeah, I say all these you all feel scared. It's actually not very scary, right? And make sure when you do all these, you don't switch on. Okay, so once you put everything in place, this one all pressed down in place, then you close the cover, then there's a screw there, then you actually just screw the cover itself. Then your plug can be used. Okay, so it's a very easy thing to do. The skillful thing that you might need to have or possess is practicing how to strip the edge of the insulator out so that you can actually screw in properly. Okay, that is the part that need a bit of experience and skill. After someone teach you 1 or 2 times, it should be quite easy. Because if you use a scissors and cut all the way, the whole thing get cut. So you must know how to cut halfway, then you strip away the insulator without cutting the copper wire. Understand? Okay, now after I explain all this, do you all actually practice this before in school? Have you seen this in school before? Okay, so now looking at this question, what would be the error when you plug like this? First of all, tell me what is the error, and the error can do what effect? Okay, let me know now. They give me the answer now. Everyone start again. Oscar incorrect. Ryan, Oscar, correct now. How about the rest of you? Okay, so can you see over here? Your yellow and green wire is supposed to be an earth wire. Your brown wire is supposed to be the live. Your blue wire is supposed to be the neutral. So your live is connected correctly. Your neutral is connected correctly. But your earth, this one got the strip one, the strip coloring is also connected to the live. So when your earth is connected to the live, and remember, why do you need an earth wire? Because your appliances has a metal casing, so you need to earth it so that you don't get shocked. Okay, so to earth it, you need to connect to the earth point in your 3-pin plug. So instead of joining to the earth, you are now joining this wire to your live. What happened? Your metal casing will become live. Okay, your metal casing will become live. And therefore the answer is B. Clear? Oscar asked me a very good question. Would the fuse blow when there's too much current in the earth wire? Okay, at first, when you plug this in, there shouldn't be any current flowing through the metal casing, because the metal casing doesn't have a 0 point for a current to flow. Understand so far? So there's no 0 point. There's like no complete circuit. Like down here you have a 0 volt. So there's no complete circuit for current to flow. So therefore it will not fuse at first. But of course, once you touch it, current will flow, right? It might fuse. Okay, it might fuse. Okay, but for a start, when you connect wrongly like this, you will not fuse immediately. Understand, Oscar? Okay, very good question. Very, very good question. Okay, the next question now. So this question appeared 2 times. It appeared in 2014 as well as 2019. Okay, other than this question has a bit of calculation. I show you all my electrical bill for last month. Did you actually go ask your parents, can I see the electrical bill? How many of you did that? Give me a yes reaction if you did. If you did not, give me a no reaction. Okay, most of you did not. In fact, all of you. Oscar, how about you? Did you actually ask your parents to show you or did not? So can you please tonight go and ask them to show you? At least you can appreciate better what is happening. Okay, can you all do that? Ask them to show you, then you understand how, and then you're able to appreciate the next question. Okay, and then also all of you go and look at your air conditioner. Go and see what is the power of your air conditioner. Is that clear? Then you go and calculate how much does it cost to on your aircon for 10 hours. And you do that every day. Okay, then you see how much will it cost. Can you all do that? Okay, so let's do question 35. Right, ask me to go faster. Okay, do 35 now. All of you do that now. Okay, Yuting, Oscar, well done. Okay, Hao Rui, well done. Bei Kuan, well done. Qiao Xing, well done. Last student. Okay, to find how much the thing costs, right, you must find the energy cost. You know, energy is power times time. And for power times time, your power is in kilowatt, your time is in hour. Clear? Okay, so for this device, the power is 0.06 kilowatt multiplied by the number of hours is 10 hours. From there, you know that is 0.6 kilowatt hour. If 1 kilowatt hour is 30 cents, 0.6 kilowatt hour will be 18 cents. Okay, most of you are able to do this question. Well done. Let me continue. Okay, so same thing. Can you look at your air conditioner? Let me see my aircon is what's the wattage. Okay, wait, I can't tell what is the wattage of my aircon. Let me Google the answer. My Daikin aircon, what is the power? Okay, after I Google about this aircon, hold on for a while. The input of the power is about 4 kilowatt. Okay, 4 kilowatt means every second it actually uses 4,000 joules every second. Okay, so that is the power of an air conditioner. Okay, so for example, if you were to use this aircon for 10 hours every night, your energy consumption will be 40 kilowatt hour. Clear so far? And we use the same example here. It costs 30 cents for every 1 kilowatt hour. So how much will it cost to run this aircon every night? It will cost you $12. So can you imagine, just on the aircon for 10 hours, you need to pay $12. Is it a lot of money? Is it more than your pocket money? Okay, so if you want to save money, can you imagine you on your aircon for 10 hours every night, and you do that for every night, 30 nights. Okay, your aircon bill alone will be $300 over. Okay, let me look at one more thing. How much is the cost now? Remember I showed you all the costing, right? The per unit right now is, okay, I'm looking at my bill again. Now it's not 30 cents. I'm looking at my current bill. Every kilowatt hour is 27.94 plus 7% GST. Okay, so GST is now 7%. Yeah, so it's about 30 cents per kilowatt hour. Okay, so can you imagine if your aircon uses 4 kilowatt air conditioner? Okay, you need to pay $12 just for it to run for 10 hours. Okay, Beikwan, you're saying what? Watch movie. You go watch movie, it actually cost the air condition for the shopping center is even more expensive. Of course, Beikwan say that you on aircon for 10 hours, you can go watch movie. Okay, I understand. Okay, so are you clear about this? So right now, it's about 30 cents per kilowatt hour based on my bill, and that is a Singapore power bill. Some of your house, you actually sign up for a retailer, which can be lower than this rate. So if you were to sign up for a 3-year contract, maybe about 2 years ago, the rate can be as low as 18 cents per kilowatt hour. So it's much cheaper. Okay, why is this thing so expensive now? Okay, because the oil prices has been going up a lot over the past 6 months. Okay, one of the main reasons is the Ukraine war. Okay, because of the war, the oil prices went up because a lot of countries are trying to boycott Russian's oil. So when there's less supply of oil, price go up because the people still need to use oil, right? But there are less supply of it. So prices will go up. Okay, this is economics. So I'm just sharing with you a little bit of economics theory. Okay, next question. Okay, do question number 36. Okay, you may begin. Okay, this one should be easy. Okay, now movie $12. When I was student, right, I think it was $8. That was like what? 3 years ago? I know lah. About 20 years ago. Is it 20 years ago? How old am I now? Yeah, 20 years ago. Wow, I sound so old now. Okay, Oscar, well done. Qiao Xing, well done. Yi Ting, well done. Next 3 students. Hao Rui, well done. Left with Ryan and that's all. Ryan, what's your answer? Ryan, incorrect. So you must remember, safety devices always connect to the live. Metal casing always connected to the earth. Okay, Ryan, what's your answer? Well done. So all of you got this correct now. The answer is D. Is that clear? Okay, next question. Okay, do question number 34. You may begin. Okay, Xiao Xing correct, Bei Kuan try again, Yu Ting correct, Hao Rui correct. Bei Kuan, well done. Ryan, well done. Okay, so it does not light up means there is no current. So which of these 4 reasons will give you no current? Okay, Bei Kuan try again. Okay, Bei Kuan is telling me B. Okay, why B is wrong? For example, for this light bulb, it may take about 5 ampere for it to work. Okay, for it to work. So this is my live wire. If my fuse has a rating of 100 ampere, so if this rating is super high, okay, current can still go through, then it should work. Unless it is so high that the light bulb actually bursts, okay? But it has a very high watt, so higher current shouldn't be a problem. Okay, so fuse in the fuse in the circuit, if it's too low, for example, I use a 1 ampere fuse, okay, and then you need 5 ampere to light up the thing. So when 5 ampere of current flow through, the fuse will break. So if the answer here is low, then B might be correct. Okay, so therefore for this answer, okay, your neutral is not connected. Okay, it's not connected. So there is no closed circuit, therefore your bulb will not light up. So the answer for this is C. Is that clear? Okay, let's do the next question. Do question number 35. You may begin. Wei Kwan, well done. Yu Ting, well done. Oscar, well done. This is a similar question. All of you should get correct. Xiao Xing, well done. Hao Rui, well done. Now left with Ryan. Okay, very good. All of you get it correct. The answer is B. Well done. Okay, let's go to the next question. The next question you haven't learned yet. I'll skip. I'll go to 20. Wait, let me see. There's no question from this year, man. Okay, you want to try question 13? Okay, I haven't teach your transformer yet. Okay, first I just want you to do is this. In your chat, calculate the power of this. Okay, the part on the left is called the primary. The part on the right is the secondary. Okay, so this is your primary circuit. So can all of you now calculate the power by the primary circuit? Can all of you do that now? What is the power by the primary circuit? Can all of you do that now? Type out the answer. Okay, Chelsea, well done. Oscar, you got it correct. Very good. Wei Kwan, I need your unit. How your answer is correct. Well done. But my question is calculate the power of your primary, the primary circuit. Okay, Wei Kwan, well done. Yu Ting, well done. Hao Rui, well done. Okay, so all of you are able to calculate P is equal to VI, and therefore your P has a power of about 26 watts. Okay, so a transformer, this is a transformer. This thing is made of iron ore. Okay, you're going to learn that in the last few topics. Made of iron, okay? This is made of iron, okay? Something like electromagnet with a coil over it. So you actually make this whole thing magnetic. Okay, so whatever electrical power here can be transferred to the right side by magnetism, okay, by electromagnetism. Okay, and then you can see that the input is about 36 watt. The output is about 24 watt. So this is the output. This is the input. Okay, so if the input is 26 watt, there's some loss of power. So how efficient is this transformer? Can everybody calculate now? Then later I'm going to share with you why do we need to do this kind of funny thing? Why do we need a transformer? Okay, it's not that it's not the movie Transformer where you can change from the robot to a human to a man-like robot to a car. Okay, that is also Transformer. Okay, but this in engineering, this or in physics, this is the proper transformer that you are going to learn. Okay, not the car become a robot transformer. Okay, very good. Okay, so efficiency, if you to understand, will be the useful output over input. Okay, and then from here you can see output is 24, input is 26. Your answer should be around 0.9. Is that clear? Okay, so answer for this is 0.9. Okay, so you may tell me, you may ask me, why this world need transformer? Why don't just use this? Okay, why don't just use this? You know what I mean? Why do I need to transform the power to another thing? Okay, so a transformer, okay, a transformer is used to either step up or step down certain things. Okay, you either step up or step down the voltage. Clear so far? Why? Why? Why do we need to step up and step down? Okay, over a long distance, imagine a power line. In other country, there's a lot of power line. Power line can go through many kilometers. And if your current is very high, you will lose a lot of electrical energy. Okay? So if you want to maintain a high power or the high energy, you want your current to be as low as possible so that you do not lose the energy through heat. So when your current is very low, you need to make your voltage very high as possible. Clear so far? So in the power station, when you want to transmit all this electrical power to your home, they will use a transformer to step it up so that your voltage will be very high. And because the power is the same or slightly reduced, your current will be very low. And when your current is very low, you lose very little energy. Make sense? Then, when it's near your home at the end, because very high voltage cannot be very useful, because imagine your radio, they give you a 10,000 volt thing. It will not work, right? So you need to step it down. So the stepping up and stepping down is used by this transformer. So how does this work? It works by looking at these two solenoid. So in this case, can you see there's a lot of solenoid here? There's less solenoid here. So from left to right is stepping down. So from more to less. Is that clear? So you roughly understand why we use transformer? Okay, why do we need to have this sort of funny thing? Why don't we just connect the wire all the way? Okay, if you understand now, give me a clap. If you don't understand, it's okay. I'll explain that in the transformer topic. Okay, did I help you understand what is a transformer and why we need a transformer? Wei Kuan, you okay? Wei Kuan, are you there? Okay, next question. Let's do question number 33. Okay, you all may begin. Okay, what do you think is the answer? Yiting, correct. Hao Rui, correct. Bei Guan, correct. Qiao Xing, your leg is also insulator. So do you think I should ask you to go and step onto the high voltage transmission line? Ryan, well done. Sorry, Ryan, Ryan, well done. So can you see in the transmission line, we use high voltage so that your current is low. Understand? So that when you transmit the electrical power from one point to the other, because of the low current, you will lose less electrical energy. Okay, Xiaoxing, we humans are also insulator of electricity. So do you think it's a good idea for you to go and touch the wire on the transmission line? The answer is no. So what is the answer? Okay, Oscar, incorrect. Yes, all of us has high resistance body, but if there's a potential difference, you go and touch a live point, you'll get electrocuted as well. Oscar, your hair on your head is also an insulator, so that's incorrect. Okay, Chelsea, Oscar, well done. Okay, so for bird on this string, on this wire, it's okay for them to land. Why? Maybe at this point is 10,000 volt. The other point is also 10,000 volt. So both point 10,000 volt, there is no potential difference. The bird will not get electrocuted. But the same wire, this is you on the ground. Your two hands go and touch, you'll get into trouble. Why? Same thing, is also 10,000 volt. Here also 10,000 volt. Why the bird can survive, but you using your two hands go and touch the wire, you'll die? Why? Okay, why will you die? Okay, very good. Some of you understand? Because for you, you're stepping on the ground, which is 0 volt. So current can go through your body to the ground, so you'll get electrocuted. Whereas for a bird, they are not touching anything, not touching the tree, not touching the ground. So the current will not flow through the bird. Understand? Because the only 2 point touching is the wire. Unless the bird stupid, one leg on the wire, the other leg holding to the wooden part. Like that, the bird will die. Okay, because one leg is 10,000, the other leg is 0, then this bird will become roasted, barbecued bird. Understand? So the blue bird will die. How Ray asked me a question. What if you wear rubber slippers? Won't try lah. Okay, the reason why don't try is because whatever you're wearing is still 0 volt, correct or not? We human body also has a high resistance. We do not conduct electricity. Okay, so but when we touch high voltage wire, we will still get electrocuted because the voltage is so high that electricity can be forced through our body. Okay, so let's not try. Okay, next question. Question 35. Can all of you look at 35 now? Let's do this question. Okay, this one got to do with the 6 formula that you need to know. Okay, Xiaoxing and Hao Rui, well done. Oscar, incorrect. Yiting, well done. Ryan, try again. Bei Kwan, correct now. Oscar, correct now. Okay, do you remember the formula? Power is equal to VI. Correct? This question, you have the resistance. Okay, you also have the voltage. So there's no current. Okay, so V equal to Ri. I is equal to V over R. Okay, hold on for a while. Okay, so let's replace the I equal to V over R. So your answer will be now V square over R. So your power is equal to V square over R. And since your R is fixed, if your V is doubled, your P will actually be square of it. Okay, so for this question, okay, only Oscar got it correct. Okay, Oscar, it's not Oscar. Yes, Oscar initially got it correct. So the answer for this question should be D. Is that clear? Okay, so for this question, most of you count wrongly. Okay, so the answer for this will be D. Because your resistance do not change, but your voltage is actually doubled. So when something doubled square, your P will be doubled square, which is 4 times. Is that clear? Okay, so for this question, the answer is D. Okay, most of you give me C, which is incorrect. So some of the smaller answer give me is C. So C is actually wrong. The answer is D. Okay, if you are clear about this, give me a clap. Okay, if you know the answer is D now, give me a clap now, everyone. If you're still not clear, okay, give me a cross reaction. Okay, let's go to the next question. Okay, do question number 34, everyone. Okay, Yiting, well done. Oscar, where do you put your protective device? Qiao Xing, incorrect. Oscar, incorrect. What is the purpose of a fuse? What is a fuse used for? Bacon, well done. Oscar, well done. Qiao Xing, well done. Okay, a fuse is to make sure that you don't get too high a current flowing into your appliances. Okay, if your current is too high, the fuse will burn. You'll cut off the current. Why? Because when current is too high, it may overheat the wire or your electrical appliances. Understand? And remember, all your safety devices should be wired at the live wire. Okay, so live wire will be correct. So for this question, the answer is B. Is that clear? Okay. Now let's go through some more. Let's go through a question that you've done before. The 2019 question I mentioned just now. Okay, let's look at this question again. That appeared the second time in the past 10 years. Okay, all of you do this question. Okay, Oscar, Qiao Xing, Hao Rui, Bei Kuan, Yu Ting, correct. Who's the last student? Who haven't given me the answer? Where is Ryan? What's your answer for this? Quickly. Ryan, where are you? Ryan, I've gone through this question. You still can give me the wrong answer. Okay, correct. Okay, answer is B, because your earth wire is connected to live. Okay, so the answer is B. So when your earth wire is connected to live, your metal casing is connected to live, your metal casing become live. The very last question for today. The very last question. Last year's paper. Last year's paper. Let's try this question. Okay, you may begin. You may begin. This is a simple question. What is your answer? Okay, all of you can get this question correct. Well done. Yu Ting, well done. Oscar, well done. Xiao Xing, Bei Kuan, Hao Rui, well done. And Ryan, what's your answer for this? Well done. Okay, that's all for today. Before I go, can you give me the 6 formula? Okay, 6 formula that you need to know for this topic. Next week, we'll do the structure question. Then we'll go on to the magnetism chapter. Okay, give me the 6 formulas. Once I call your name, you may leave. At the same time, tell me how you find today's lesson. How much did I value add to you? Okay, Oscar, you may go. Chelsea always give me low rating one. I feel very hurt. Chelsea, you may go. Bei Kuan today not very high. What happened? You learn already. Bei Kuan, you haven't give me your formula yet. Ryan, you copy and paste your formula so fast, give me. Ryan, you may go. And Yiting, you may go. Bei Kwan, you may go. Wait. Bei Kwan, your first formula wrong. Give me the E equal to PT. Can you expand that? Hooray. Hooray. You may go. Okay, Bei Kwan, your E equal to PT. Can you change that to a longer formula? Okay, Bei Kwan, you may go. Yiting, have you given me your answer yet? You got any question for me? Okay, Bei Kwan, you may go. Yiting, you haven't given me your formula, right? Okay, thank you, everyone. Good night.